Hi, and welcome to this example of Sonic Pi playing some Midi to Logic Pro, which is over here, but controlled by means of a graphical interface with a processing script which controls the transport mechanism. It starts Sonic Pi playing, it stops it, and it can restart it again in the way which I'll explain a bit later on. Also added to the program is the ability to set the bar at which we start playing. We can either set start playing at bar 1, or we can increase the start bar to a given number or reduce it. So how does this all work? Let's first of all just see it in action. I'll click on Sonic Pi and I'll use the shortcut Command R to start the program running. And nothing happens at the moment. We're just waiting for things to get going. So to get them going, I'm going to click on the play rectangle here in the processing script, and it starts playing. And you can hear and see the instruments going. This is a sort of fugal piece by Bach. Starts with a bassoon, and after about 5 bars, the second part, which is an oboe, becomes an about now. There it goes. And after a few more bars, I think in bar 15 or thereabouts, we find that the first of the flute parts comes in. About now. And a few bars later, in bar 22, the final part will start playing here. As this plays, you can see all the MIDI information being sent from Sonic Pi, which, as you see, there goes the final flute part, by Logic Pro, and is playing there. So let's stop that playing, which I'm going to do by clicking on the stop button here. And you can see the whole thing stops, but it hasn't actually fully stopped, because what the stop button does is to stop it playing, but then to start a new instance of the program playing again, so that we're ready to click on play again, like this, and it starts playing again from the beginning. So we'll stop that playing, but let's see how we can start playing at a different position. If I click on the bar start plus button, I can actually increase the bars at which we start, and if we take say bar 5, I think it is, let's start playing from that one. No, it's not quite there. Perhaps if I have a look, let's have a look at the score, and we can see there's bar 1, 2, 3, 4, 5, 6, 7, bar 8 it is that we start playing. So let's go back to Sonic Pi here, and back to the we'll just hide that muse score first. There we are, and we'll come back here and we'll set that to bar 8. There we are. Start playing. And we start playing as the second part comes in there. And we'll try that again, stopping by playing in bar 12. No, 15. There's the third part starting. Stop that playing. Change that to bar 22. And start playing. There's the final part coming in. So you could see how we can actually control it like that. The question is, how does this all work? Well, let's start by having a look at this section, which is the processing script. And if I bring that up here, and we just open up the sketchbook, which is the name they give these scripts to, that we're actually playing here, which is this one here. And we'll just make the page a bit bigger so you can see a bit more. There we are. This is a nice scripting language that produces a graphical output, but it can interact in lots of ways, and here we're using 2 libraries, one so that it can send OSC messages, and the other which enables it to have understand network addresses and so on. And we start off here in the setup process by first of all creating a UDP OSC socket here on socket 8000 and putting in the details of the address of our local machine, the Sonic Pi, which is in the local machine 127001 and is listing on port 4559 for OSC messages. We then create this screen down here, which has got 5 rectangles on it. Here they are produced. This is the one which is marked BS plus, and then so on. And then we also, so that we know which one is which, put some captions on them. The stop, play, BS plus, BS minus, BS1, and the text for the starting bar, which started at 1 but has now in fact been changed to 22, which is there. Then we have a little script which is going to send an OSC message. The script is recognized by this name /transport. It's dealing with the transport of Sonic Pi, playing and stopping. And we're going to add to it 2 parameters, TR, which is the transport variable. When that's 1, it will start playing. When it's -1, it will stop. And then secondly, the bar start number, which is just an integer 1 up to however many bars there are in the piece. And then we send that information to Sonic Pi. In the main script that we have here, the main loop, we look at the mouse X and Y positions, and if the mouse button is pressed, this section here tests to see whether we're in the BS minus box, and if so, it's going to subtract 1, BS minus equals 1, subtract 1 for the value of BS. If it goes negative, it sets it equal to 1 again, because it's obvious, it's nonsensical to have a negative bar start. And similarly for the BS plus clicked box, if that is clicked up here, it will increment the value of BS by 1. And then the next box, which is BS equals 1 clicked, is going to just reset the value of the bar start variable to 1. Then we have the play command box, which is here. If that is clicked, it sets the variable TR to 1, and it's going to send TR and the current value of the bar start to Sonic Pi in an OSC message, which acts like a sync command in Sonic Pi, as we'll see in a moment. And the final one is if we click the stop button, that's going to set TR to -1, and it's going to send that and the current start bar, although that will be ignored, to Sonic Pi. And this final section down here deals with printing the value of BS on the screen. In order to do that, we first of all have to print a blank rectangle in the background color, and then write the text on top of that, because otherwise they'd all write on top of each other and you just end up with a mess. And then finally a loop before we go back and start this, a delay before we go back and start this loop again. So that's how that section works. Let's just minimize that and get rid of that, and we're back to here. So let's now see how the Sonic Pi program interacts with this. If we go back to the beginning, we can see here that we've got an until end loop which goes on running until a certain condition is fulfilled, and that condition is that the parameters received by the sync command here, the first of the second of these, which is the first of these, which is S0, is equal to 1. That's the value of the TR variable which was sent. If it's equal to 1, then we've got a go, we can go ahead. If on the other hand it's not equal to 1, then we would not be able to proceed beyond here. Now, when that happens and it receives that TR equals 1, it also can look at the second parameter which is sent, S square brackets 1, which is the value of the start bar, and that is put into the BS variable. It's also printed on the screen. We then start the main part of the program, which runs from here And the first thing we do is we start a thread which is going to be looking continuously for another sync command to be queued from the processing script here, and that in this case it's waiting for the first parameter, the tr variable, to be set to -1. But if that is so, then we've sent a stop signal to Sonic Pi. So how does this actually work? Well, what it does is that it runs an external system command, which is going to run an auxiliary script, which I've called BWV5888 auto. BWV588, this is just the Bath catalog number 588, which is the number of this particular piece. And what this particular script is going to do is to use the command line interface to Sonic Pi, and it's first of all going to send a stop command to Sonic Pi, which will stop all the programs running on it, and then it's going to send a run file command with the name of this particular script in it, and it will start it running again in a second instance. And so it goes back to the beginning and is waiting for another play command to trigger this and then proceed on to the program. Well, assuming we haven't sent a stop command, we go on to the rest of the program. Now, the program is, in this case, going to play Midi or send Midi note output to my Midi player, which is actually Logic Pro that we have here. Oops, something funny, it's come back in. Which is going to send it to Logic Pro, which is my player. And this is connected by means of the audio MIDI setup. And here I've set up a session, and I've got it listening to localhost, which is this address 192.168.185. I haven't sent up any routing outside the onto the network because this is all on the local machine. But we could have been playing Logic Pro on another machine, and in this case I simply can send the messages for this particular session called Logic Pro externally onto my network, and it can be picked up by another machine. And equally, this processing script can run on another machine, and because it's addressed to the Sonic Pi address, if I put in the actual IP address rather than the local machine address 127.0.0.1, then it can receive this from another machine. So the MIDI from here is picked up here and is fed to the various instruments. And if we expand this a little and we look at the first instrument here, you can see that that is looking at MIDI channel 1. The second one is looking at MIDI channel 2, MIDI channel 3, MIDI channel 4. Alternatively, I can switch to this harpsichord, which is looking at all the MIDI tracks, and it amalgamates them all and can play it instead. If I just show you that quickly, we do that and start playing from Bath 22, you can hear it's now playing on the harpsichord instead of on the 4 individual instruments as we had previously. We'll stop that again and say a little more about the program. The MIDI play routine takes a series of notes and corresponding series of durations. It is specified which channel, which MIDI channel you're going to output on. S equals 0, this is how we're going to actually start at from other than the beginning of the instrument. It's actually the number of beats into the piece that we're going to start playing from, and we'll work out how we calculate that in a minute. Finally, I've set the velocity with which the keys are pressed. If you imagine it's a keyboard instrument, if you press a key hard, then you'll get a loud sound. If you press it gently, you'll get a softer sound. And this, if you like, is the volume. And it goes from 0 to 127. Well, I've set it at the beginning of the program for all the channels, in this case, to be equal to 100, about 80% or so. Then we go round a loop, starting which goes over the notes we're going to play, starting at S. Now, if S is 0, it starts at the beginning. If S is another note, it's going to start in the middle of the piece. And then we're going to play the MIDI notes. We first of all check to see whether there's a chord. I don't think there is in this particular piece, but in some pieces we have a chord, in which case we're going to play several notes, MIDI notes together without having a delay, a sleep between one and the other. Otherwise, if they're not a chord, it's a single note, it's going to send the MIDI information, and it's going to send what the note is, what the duration is, what the channel is, and then it's going to sleep for the duration of the note before it goes and gets the next one. Now, in order to work out where we're going to start, we need to work out how many notes there are that have been played before we get to a particular bar. Let me illustrate this by looking at the music again. If, for example, we wanted to start playing here at bar 1, 2, 3, 4, then we would have to set the starting position for this particular track to 1, 2, so they start counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So S would go from 9 up to the duration of that track, and it would start playing there. Now, the problem is that different tracks will have different numbers to get there. To start this track playing there, we start at 0, 1, 2, 3, and the same for that one and for that one. And so this has to be calculated. If we hide that again and come back here, that's what's done with this particular routine. What it does, first of all, is to take the starting bar, subtract 1 from it so that we start counting from 0, and say that the beat we want to start counting from, which is match beat, the beat we want to start playing from, is the number of complete bars into the piece multiplied by the number of beats per bar. That gives us the starting beat. And then what we need to do is we need to go on adding together the durations of all the notes starting at 0 until we get to the case where the duration is greater than or equal to the match beat. And in that case, we return that number. If we've gone a bit further, and this will occur if we get a tied note across the bar line, then we need to say how much over we've gone by subtracting the match beat from the actual length, duration that we've got to, and we can actually use that to synchronize even though we don't actually start playing on the start of the bar for a particular part. And that is done down here. This is the first part. It has a stream of notes, some rests before it comes in, then notes start playing there. This is actually, in fact, they're put in an odd order. This is actually the first track, which comes in fourth. It's the last track to come in. And what we do is that we work out the match for this, starting at the given bar we want to start from, looking at the durations in here, and we're going to print it out here. And then we're going to start playing from that particular position in the case. The returned information, there's two things that come back from SV1. It's going to return both the starting position and the sort of error, the overrun, if you like, before we actually start playing. And the way we get rid of that overrun is by sleeping for a certain period of time before we start playing, which we see up here. Now I can explain this better by actually having a look at it. If we go back to have a look at the script, at the score, supposing we were to start on this bar, that's bar 1, 2, 3, 4, 5, and 6. What we're going to find, if we put that in here, bar 6, we'll go back to 1 and go up to 6 again. 5, 6. I'm going to hide that again, and I'm going to start that playing and then stop it almost immediately. Because what I want to do is to go and have a look at this. And you could see that for this part, we're going to start playing at the 17th note, starting counting from 0, and we're going to sleep for 1 beat before we actually start playing. Let's go back to the script and see how that works. Starting to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's where we're going to start, but we're going to sleep for 1 beat, 1 crotch hit before we start playing. So this part would actually start coming in slightly after the beginning of that bar. We're going to ignore the second half of that tied note and start playing there. And that's how we can actually start this. If we look at the other parts, you can see that all of them start on the 5th note and the 0 sleep before they start playing. And if we look here, we can see that for this part, we've got 0, 1, 2, 3, 4. We're going to start the 5th note with 0 sleep. So that's going to start there, that's going to start there, that's going to start there. So everything starts synchronized here, except that we sleep for 1 crotch hit before we start playing that there. So that's how we can actually start playing for different positions using this bar start mechanism, which we can see there. Let's hide that again. Oops, hide this again and go back to here. And that's really all there is to it. The other parts are exactly the same as they go on here. And so that gives you a brief indication, not very well explained, I fear, as to how we can actually use this transport mechanism, and we can arrange to start at different places. This would work even if this wasn't playing MIDI, if it was playing just ordinary notes using this panel, and provided we add these scripts in here, we could actually use this to start any Sonic Pi piece at a known position inside the script. There are certain simplifications. We're assuming that there aren't tempo changes within the piece, although we could actually still accommodate them. But the way that's done in this particular piece, although there's only 1 tempo throughout, is that when the tempo changes, we get another set of information here. So we've got A10, B10, and C10 effectively is 120. If we change that to 1 and that to 1 had another section here, we would have another entry in here, 120, say 90, if we had the tempo slowing down. And we need to do a bit of fiddling around with these routines in order to get that to work. So quite a lot been going on here, even more so in order to record this, because also running in the background I have a little program called Audio Hijack, which is taking the output from the Logic Pro application and from the microphone. It's feeding them both to the headphones I've got on and to the Capto device, which is feeding into the screen recorder, which I'm using in order to record all this. So it took quite a lot of setting up, but it seems to be working quite well. So to conclude, let's just go back to the beginning by doing that, and we'll listen to this playing on the harpsichord. Get that on the screen. It has slipped up. Perhaps just show you a bit more of that as it plays, so that you can see a bit more of the information. You'll notice the channels feeding the notes to different things. If you look at the velocities, you'll see velocity hundreds for the note ons. Each note on is accompanied by a note off command at the end of the duration of the note. That you can also set the release velocity, but this is just using the default, which is 127, so the note stops fairly abruptly at the end of that time. I have also done experiments on doing crescendos and diminuendos using Midi, because you could simply put things in a loop and slowly increase the vel parameter as the notes play, so you can get a crescendo and then reduce them again to get a diminuendo. So Midi brings a whole new dimension to Sonic Pi, as does the facility to receive external OSC synchronizations. And if you could just get added to Sonic Pi a built-in command to stop all, and a built-in command to perhaps run a specified buffer, that would be really great, and could do away with the script, external script, which I'm using to restart. But what we'll do is just fade that out here, do it nicely on, leave it playing, just fade it out here. Still churning out from Sonic Pi, and we can put that out of its misery too by pressing the stop button, which just restarts it ready to play again. And I hope you've enjoyed that video. I'll just come up and stop it.